All right, ladies and gentlemen, welcome to the fifth and final video of examples of transversal proofs. Again, these are the proofs that are coming out of Chapter 3. In Honors Prep Geometry, we are using them to develop freedom, to develop an ability to think, to develop the ability to do proofs without all the scaffolding of a fill-in-the-blank proof system. So again, this video is going to contain two proofs. The proofs shown in this video are not by any means the only, the best, the shortest solutions. They are just correct proof solutions, fully vetted, fully correct, fully in the correct order. So they're just one way to do the problem. It's not by any means the only way to do the problem. All right, so here we go. The first proof is extremely straightforward. It's just another example of a pretty standard transversal proof. We start off with our givens. The measure of angle 5 plus the measure of angle 11 is equal to 180 degrees. In addition, line M is parallel to line N. Those are our givens, which means that we are allowed to use our theorems and postulates for transversals across lines M and N. We're not allowed to use them across lines B and C. What I mean by that is these 8 angles form a transversal set that we can apply rules to, and these 8 angles form a transversal set that we are allowed to perform our theorems and postulates on. We are not allowed to relate these angles or these angles because those would require that we've stated that B and C are parallel, which is actually what we're trying to prove. So, our given includes angles 5 and 11. Again, if we look at the picture, angle 5 and angle 11 are not related to each other. So what we need to do is come up with a relationship between angle, one of those angles, and an angle at a different point of intersection that also has a relationship to the other angle. What I mean by that is we need an angle that is related to both angle 5 and angle 11. And I suggest very heartily that you find yourself an angle that is actually congruent to angle 11 down here at this intersection, 13, 14, 15, and 16. I would highly suggest using angle 14. Okay, if we look at that picture, angle 11 and angle 14 must be congruent. The reason that they must be congruent is they are alternate interior angles. And the alternate interior angle theorem says that since line M is parallel to line N, each pair of alternate interior angles, 11 and 14, and 12 and 13, which is not useful to us, 11 and 14 must be congruent. If 11 and 14 are congruent, then the definition of congruence says that the measure of angle 11 is equal to the measure of angle 14, because that is what the word congruent means for angles. If two angles are declared congruent, their measures must be equal. The only reason, once again, this is much like one of the proofs in the early video, the only reason I would go about doing that is so that I can substitute, so that I can replace the measure of angle 11 in my given with the measure of angle 14. So I'm going to take measure of angle 14 and plug it in up here for the measure of angle 11. That would give me the measure of angle 5 plus the measure of angle 14 equals 180 degrees by the substitution property. Now the reason why that's valuable is because angle 5 and angle 14 have a vocabulary word that describes them. They are outside of the parallel lines, or they're outside of the lines, which makes them exterior. They're on the same side of transversal M, which makes them consecutive. And the converse, the consecutive exterior angle theorem, says that if a pair of consecutive exterior angles, like 5 and 14, are supplementary, which is what we've stated here, 5 plus 14 adds to 180, that is enough to declare that the lines that they lay on, in this case line B and line C, are parallel. So we would finish this proof by saying the converse of the consecutive exterior angle theorem. Done. Okay, that brings us to our final proof of our notes. Now this final proof is again an example of a proof that I wanted to show because it is something we can do with transversals. It is extremely similar to something we did back in Chapter 2, Section 8. But before we can do all that algebra, we have to get the problem set up correctly. We have to get the equation in the right place. So the final proof in your notes states that a couple givens, and then we're asked to prove that the measure of angle 7 is 108 degrees. So like any other proof, we start off with our givens. The measure of angle 9 is equal to 2/3 times the measure of angle 7. We're also told that line B is parallel to line C, and line M is parallel to line N. Now those are great givens to have because that means we can use any of our rules across any of these lines because we have enough information to state that both sets of lines are parallel, which means we can relate any angle to any other angle in the picture using our vocab. Now what we need is we need an equation that relates the two angles in the given, 9 and 7. But 9 and 7 do not have a direct relationship. So our first step is going to be to establish a relationship between angle 7 and angle 9. So we need to find another angle in this picture that is related to both angle 7 and angle 9. Now when I look at that picture, what jumps out at me is that angle 1 and angle 9 are corresponding angles. So that's where I would start. I would say angle 1 is congruent to angle 9 because of the corresponding angle postulate. The reason I picked angle 1 is because angle 1 and angle 7 are consecutive exterior angles, which means I can write the equation measure of angle 1 plus the measure of angle 7 is 180 degrees, because that is what the consecutive exterior angle theorem says. It says that if the lines are parallel, each pair of consecutive exterior angles has to be supplementary. Now notice that I am now able to change my statement in 2 from a congruent statement into an equation using the definition of congruence. And much like I've done in other proofs, I'm then able to substitute and plug the measure of angle 9 in for the measure of angle 1 in step 3 to give me an equation that relates the measure of angle 9 and the measure of angle 7 to each other. I have shown that they must add up to 180 degrees. Now the reason why that is useful is because now, using that equation in step 5, and my equation I was given, angle 9 is 2/3 the measure of angle 7, I can get to an equation that only contains one variable, the measure of angle 7. So what I do is I take my given, which says that the measure of angle 9 is equal to 2/3 the measure of angle 7. I take this, and I plug that in for angle 9 in step 5. Now I'm going to reduce my pencil size because it's going to be a little bit hard to write this out. So I plug in 2/3 times the measure of angle 7. Oops, I don't really want that to be in parentheses. Let me rewrite that. The measure of angle 7 plus, and I still have another measure of angle 7 because this is the yellow part, and then I still have the rest of the equation, equals 180 degrees, which is the substitution property. Okay, so it's back-to-back substitution properties. I'm combining the two equations I had to work with into one equation. Now this is where algebra proof takes over, because now what we're going to do is we're going to solve for the variable. If that said 2/3 x plus x, we would immediately know from algebra that we're supposed to add like terms. We're supposed to add 2/3 x and x together. So 2/3 measure of angle 7 plus 1 times the measure of angle 7, we would add 2/3 and 1. 2/3 plus 1 is 2/3 plus 3/3, which would be 5/3. So step 7, we combine the like terms to get 5/3. I need to make the pencil smaller probably. 5/3 times the measure of angle 7 equals 180 degrees. Again, all we've done there is simplify. So while that is the substitution property that allows us to do that, we're using it to simplify, so I would expect you to write substitution simplify, not substitution property. From there, all we need to do is get rid of the 5/3. Now, in theory, we can do that in one step, but we're not going to. We're going to do it in several to make sure it's easy to follow. So the first thing we're going to do is we're going to clear the fraction. We're going to get rid of the fraction. The way that we do that is we multiply both sides of the equation by the denominator, 3. So we say 3 times 5/3 measure of angle 7 equals 3 times 180 degrees. Because, again, anytime we add, subtract, multiply, or divide in a proof, that is a two-step process. First, we show it, which is the step that gets labeled with the operation, the multiplication property, and then we simplify it. The 3's would cancel, leaving 5 times the measure of angle 7 equals 3 times 180, which is 540 degrees. That is substitution simplify. Then, to get angle 7 by itself, we would proceed to divide both sides of that equation by 5. Now remember that when we divide, that's a two-step process as well. First we show it, so we show both sides of that equation being divided by 5, which is the step that gets labeled the division property. And then we actually carry out the division, which on the left side, the 5's would cancel, leaving the measure of angle 7. And on the right side, 540 divided by 5 is what we expect it to be, 108 degrees. Substitution simplify. So there's an example of a proof that is turned basically into an algebra problem halfway through. Again, keep in mind that when we do algebra in a proof, adding, subtracting, multiplying, dividing, and distributing each take 2 steps. And anytime we add like terms, it is a substitution simplify. That does it. We've gotten through our proofs for transversals. Now you have a fairly complicated activity to do. If you need to, you can come back and review these videos. You can also email me your solutions, and I'm happy to check them for you, explain why you are or are not correct. Thank you very much for your time, and good luck on the activity.